Okay, now we're looking at final for semester 1. Final semester 1. And part 1 or 4 out of 4. Okay, so this is part 4. Time to finish. This is going to be doing Pythagorean theorem over and over and over again. Just to review, Pythagorean theorem is when you have a leg squared plus another leg squared is equal to the hypotenuse squared. And that's the big idea. And how does that really help us? Well, with right triangles, you got this pattern, leg squared plus leg squared equals hypotenuse squared. So here's our legs, 3 and x, and 5 is the hypotenuse. So that tells me that x squared plus 3 squared equals 5 squared. Well, 9 and 25 would simplify for the numbers. Then it's just algebra, subtract 9, x squared equals 16, and then square root at x equals 4. So this equals 4. Not too bad. Let's do it again. Okay, so number 77 here, I got 9 and 15. And notice that this time they gave me the hypotenuse and a leg, a lot like last time there. So x squared plus 9 squared equals 15 squared. Why did I set it up that way? Well, the big idea is that you got to do the two legs, which are the two pieces attached to the right angle. The hypotenuse over here is across from the right angle. That's how we know that. Okay, so this is going to become 81. 15 squared is 225. We got x squared plus 81 equals 225. Subtract 81. And what would you get? X squared equals, that's a 4, that's a 14, 144. Hey, that's going to be kind of cool because that is a perfect square. X equals 12. This is almost too easy. Way too easy. We're just getting warmed up though. Find the missing side of the triangle. Leave your answers in simplest radical form. Now it's not going to be a perfect, integer. We're going to get something that's kind of irrational here. Well, again, it looks like I have two legs, so x squared, or I have a leg and a hypotenuse, pardon me, so I have to put an x for a leg. X squared plus 7 squared equals 15 squared. 7 squared is 49. 15, just like before, is 225. And then we got the x squared. So I'm going to subtract 49 from each side. I know that this is going to become 176 equals x squared. And I can't really think of much that goes into that evenly. So we just leave it. X equals square root 176. If you didn't see that answer, that means there's a perfect square that would go into it. But right now I can't even think of one that would. You know what? 16 looks like it does. 16 is really close there. Let's see how many times does 16 go into 176. That's once and then twice. So 16 and 12. That means that, whoa, we got some numbers to simplify here. Let's go ahead and simplify it. 16 and 12. Square root of 16 is actually 4. 12 I could break down even more with 4 and 3. And square root of 4 is 2, so this would be 4 times 2 times square root 3, which would be 8 square root 3. So that would be our final answer. That's interesting to see it break down that much. Didn't expect that. Okay, let's keep checking this. Same idea. We got 14, 11, and x. Well, this one looks like x squared plus 11 squared equals 14 squared, because remember the hypotenuse is the third piece over here. 11 squared is 121. 14 squared is 196. And we got this x squared. So we got to subtract 121 from both sides. Easy enough, that gives me a 5 and a 7 equals x squared. This does break down, not too hard. 25 and 3 will multiply to equal 75. And 25 is a perfect square, changes to 5. So x, whoops, square root that, x equals 5 root 3. That fast, that easy. Ooh, this is interesting. When you see a radical like that, remember that the radical of something squared, let's say a, whatever it is just a. So when you set this one up, you're going to have x squared plus square root of 37 squared equals, not plus, equals 9 squared. 9 squared is 81, no big deal, but square root of 37 squared is just 37. Easier than you would think. So watch out for that kind of thing. Okay, let's keep moving here. We're looking at number 83. State if the three sides lengths form a right triangle. Okay, for it to be a right triangle means that the leg squared plus the leg squared equals the hypotenuse squared. So here's what you got to really think about. That, to me, is saying that I got to check if leg squared plus leg squared equals hypotenuse squared. The hypotenuse is the longest side. So I might be asking myself, well, wait a second, which one of these is the longest? Is it 3 root 17 or square root 13? It's kind of hard to tell. So here's how I would check it. I know that 13 squared is 169, so this would be like square root of 169 is 13. And 3 root 17 is the same as square root of 9 times 17, which would be 170 minus 9, or 161. So that tells me that this 13 is slightly bigger. So my legs would be 4 and 3 root 17, and this would be my hypotenuse, 13. So let's check them now. 4 squared plus 3 radical 17 squared, and then we're not sure, question mark, 13 squared. Maybe it's equal, maybe it's greater, maybe it's less, we don't know. So 13 squared, that's 169. 4 squared here is 8, and we actually just figured out 3 radical 17 squared, did we? Yeah, it'd be 161. So let's see if this works. Because 3 squared is 9, and square root of 17 is square root of 17. That's 161. So this is 161. Hey, check that out. They are equal because 8 plus 161 does equal 169. So yes, it is a right triangle. Why? Because it equals that. Now, if I came up with something like 160 equals 169, that would be no. That would be a no. But this up here is yes. This down here is no. So it's giving you two different ideas there. Find the area of each triangle. Round the intermediate values to the nearest 10 to use rounded value. Okay, so here's the big idea. Find the area of this triangle. Well, the area of a triangle is half base times height, or base times height divided by 2. Same thing, by the way. And they give me this height here, but I'm missing the base. So how do I find the base? Well, the base I have to find by doing Pythagorean theorem. Well, Pythagorean theorem would tell me that, let's call this x, so x squared plus 10 squared equals 11 squared. That gives me 100 here, 121 here, and this is x squared plus that. We do some algebra. X squared equals 21. So I mean x equals square root of 21. Right here, this is square root of 21. Alright, no big deal, right? Well, area then is going to be base times height divided by 2, or 10 times square root of 21 divided by 2. That would simplify, because 10 and 2 simplifies to just 5 square root 21. And you can use a calculator to get that even closer. You guys will be allowed to use calculators for the final. But that's pretty much the only thing you would need it for there. Okay, this one, I'm going to cheat a little bit. I know that if that's 90, so is this, and if that's 9 and 3, then I know that by hypotenuse leg congruence, this is also 3. Because these are two congruent triangles. How does that help me? Well, only a little bit, because now I know that the base is 6, but I still got to find the height of this full triangle. To find that height, I got to do this right triangle using half of it here. So we know that 3 squared plus the height, let's call it h. Well, no, let's not call it h. Let's call it y. Y squared equals 9 squared. And this right here is our y. Well, it's 9 plus y squared equals 81. If we subtract 9 from each of these sides, that gives us y squared equals 72. So we're going to square root each of those. Y equals square root of 72. But that does simplify. I know for sure 9 goes into it. Let's check that. That'd be 9 times 8. Keep going. Because that would be only 3 times square root of 8. And square root of 8 does 4 and 2. So I'd have 3 times 2 times square root of 2, or 6 square root of 2. So this y right here equals 6 square root of 2. Alright, so the area of this triangle is going to be base times height divided by 2, which is 6 times 6 square root 2 divided by 2. This 2 can simplify with one of those 6's. We got 3 times 6 times square root of 2, which equals 18 square root of 2. That's a lot of work. There we go. 18 square root of 2. Alright, we got special right triangles with missing side lengths. Key things to remember, that we either got half of an equilateral triangle or half of a square. Either way, we can use algebra to work our way to the pieces that we need. So let's look at 89 first. It looks like it's half of an equilateral triangle, which means that this whole side is 4, which is the same as this. And if we said these two halves here, y and y, would make 4 as well. So that means this y is actually 2. So y equals 2. And we know that 2 squared plus x squared equals 4 squared, because that's, Pythagorean relationship there. We got 4 plus x squared equals 16. Let's keep going here. Subtract 4. We got x squared equals 12. Square root those. 12 breaks up to 4 and 3, and that's our x there. We can simplify the 4 to just 2. So it's 2 radical 3. So there we go. X equals 2 radical 3, and y equals 2. No big deal, right? Okay, let's look at this square down here. We'll do it in a different color just so we kind of track what we're doing. So this blue looking square. I know that x and y are actually the same thing. So I'm just going to choose the x pieces. And I know that those two squared and then added up equal this piece here squared. So that means that x squared plus x squared equals 2 radical 3 squared. Okay, well 2 radical 3 squared would be like 2 squared and radical 3 squared. So that's going to be 4 times 3. And over here I'm going to have 2x squared. Okay, so that gives me 12 on the right and 2x squared on the left. Divide by 2, divide by 2. X squared equals 6. X equals square root of 6. Now here's the crazy thing. So does y, because they are equal. That was easy. Way easier than I thought. Okay, let's keep going. Let's see what 91 says. Or 93, pardon me. Ooh, this is definitely a little bit harder. Alright, so the big idea here, remember, is that these are half of an equilateral triangle. If it's this 30, 60, 90, it's like this up here, and then this here, and then we get an equilateral triangle. So that's x, and this is 5 root 3 over 3, and then this would be 5 root 3 over 3. Which means that x is double that, or x is 10 root 3 over 3. That's a 10. Because that's double 5 root 3 over 3. Now to find the y, you could set a Pythagorean theorem. And you'd actually come up with something that's kind of interesting. You come up with a whole number there. That's really weird. So watch this. If I say that the hypotenuse is going to be 10 radical 3 over 3, that means I got 10 radical 3 over 3 is my hypotenuse, which I'm going to square. Then I'll have y squared plus this 5 radical 3 over 3 squared. I got a Pythagorean relationship there. Let's see what happens. Okay, so for the last one, we're just going to square each term and see what we get. So that'd be 100. Radical 3 is going to be 3. And then over 3 times 3 is going to be over 9. Similarly, in this middle term here, we're going to have 25 times 3 divided by 9, and then we got the y squared. Okay, so I'm going to do something kind of fancy. I'm going to multiply everything by 9. And on the right side, that just gets rid of the 9s. On the left side, I'm going to get 9y squared plus 25 times 3, which is 75, equals, and 100 times 3 is 300. And I'm going to subtract 75 from both sides. Let's see where this takes me. I'll have 9y squared equals 225. And if I divide by 9, I get y squared equals 225 over 9. Now I'm going to square root those things. Square root of 225 is 15. Square root of 9 is 3. So there's my y value, 15 over 3. Which, wait a second, that even simplifies more. That's just, what is that? 15 over 3 is 5. Wow. Wow. That's like so crazy simplified that it's like, how did it get to be that number? All right, let's look at 95. Not quite as hard, but still's got plenty of challenge in it. So again, it's part of an equilateral triangle. Remember, this square root of 6 represents half a side of an equilateral triangle, so the other half would be square root of 6 as well. Which means this x here is double that. It's 2 times square root 6. And then to find y, I could do a Pythagorean theorem. So square root is 6 squared plus y squared equals 2 square root of 6 squared. So these two pieces, that just gives me 6 plus y squared. But on the left side, that's 2 times 2 and radical 6 times radical 6. So that's going to be 4 times 6. Keep going, that would make 24 equals 6 plus y squared. We can subtract the 6. Y squared equals 18. Square root y equals, what's going on here? This is going to be a 9 and a 2, which is really 3 radical 2. So there's my y value, 3 radical 2. And the x value we figured out was 2 radical 6. So we got lots of radicals in all three of them. All right, we're coming up on the end here, last couple of problems. 97 and 99. Okay, now these are definitely challenging. And here's what you would do to go about doing this. So first, if I were to look at number 97, this is what I see. I see an equilateral triangle here, and I see a square here. And I'm trying to ask myself, where might it be easier to start? I think the equilateral triangle would be easier, because if this is x, that means half of that is x over 2, and this is x over 2. But wait, that's a square, which means this is x over 2 as well. Now I have a Pythagorean relationship with those three pieces, which means I have x over 2 squared plus x over 2 squared equals 7 squared. Then I could solve that equation for x. So crazy. Alright, well, let's see what we would get. This would be x squared over 4 plus x squared over 4 equals 49. Keep going a little bit more from there. That's 2x squared over 4 equals 49. I'm going to simplify this 2 over 4 to be just 1 over 2. Then I'll get rid of that 2 by multiplying on both sides. So x squared equals 98. And when I square root this, guess what? I know what 98 breaks down to. 49 times 2, based on these two numbers that I multiplied there. Which is convenient because 49 is a perfect square. That's why I remembered that. So I'd have 7 root 2. Boom! Check that out. Is that it? Nah, it can't be that easy. Well, I guess it is. Well, there we go. Alright, so let's look at 99. Alright, I'm gonna cheat just a little bit here. I know that this, let's call this y and this y. And I know that y squared plus y squared equals 6 radical 2 squared, which gives me 2y squared on this side. And 6 radical 2 squared would become 36 times 2, or 72. I knew that this was going to work out because this radical 2 is really just that short side times the radical 2 is what that hypotenuse gets. So when I simplify this, I get y squared equals 36, square root each half of that, each side of that, and you got y equals 6. So this is 6 and this is 6. How does that help me? Well, it's because this other piece here is part of an equilateral triangle, and that's 6, and this is 6, and this could be 6 and 6 together, that's 12, which means x equals 12. Check that out. Now, if you didn't catch that, it's a pretty high level. That's why it's the last problem on the entire thing. I don't expect you guys to rock it like it was nothing. It's supposed to be the final, the finale, which means we are done. Isn't that awesome?